Hello once again. Oh, can't see that yet. So we have our examples that we're going to be working through in this video. Right, the three claims are there. You can read them if you need to again. We've got our null hypotheses based on those claims. Again, the null hypothesis and the alternate hypothesis don't care about the sample data. These hypotheses are based entirely on the claims you're trying to investigate. They should be independent of your actual sample data. And the null hypothesis is always an equation. It's always my proportion, or my mean, or my variance, or my standard deviation, right? Well, my statistic that I'm investigating equals some value. And your alternate hypothesis is going to be some inequality or non-equation based, again, on the claim. The sample stuff, the sample statistic, is going to be used for our test statistic. So we ended the video there, and I challenged you all to find the alternate hypotheses. So hopefully you found for me this first one. Since it said at least 20%, the alternate hypothesis should be P is greater than 0.2. For the next one, lie detectors being accurate less than 85% of the time, this should be a less than inequality here. And finally, the claim that only 1/3 succeeds, well, it's not saying greater than, and it's not saying less than in any of the language I'm familiar with. So we'll go with P not equal to 0.333 for our alternate hypothesis for number 3 here. All right, so let's start cranking out some test statistics. Yes, it is number crunching intensive, but it's nothing you can't do on your own by hand. Order of operation kicks in, you know what to do. For this first one here, we start using our sample data. We've got a sample size of n, and I went ahead and wrote it for you this way, but it had 52 out of 227 with bad side effects. So that's my p hat value. You can crunch that number, and you get about 0.229. So that's p hat. N is also based on your sample data. N is your sample size, 227 people. And P and Q for this equation is using your claim / hypothesis value. So P and Q is 0.2 because that was our claim. And of course, Q is whatever P isn't, so that's 80%. So in go the numbers, and out comes our lovely test statistic. So that goes into our table. So what I would like you to do for me right now, if you haven't, if you don't like it, sorry, but go ahead and pause this video and see what values you get for the other two's test statistics. And when you're ready, you can unpause the video, and we'll see if you're right. Did you pause the video? I bet you didn't. Well, anyway, these are the values you should have gotten for your two test statistics for the other two examples. The first one was negative 2.63, and the final is about negative 5.724. So very large negative numbers. And even without getting into p-values and p-tests and alpha values and anything like that, I want you to think back a little bit to our very early on discussion of z-scores. When we were talking about z-scores, remember we said that if something was beyond 2 standard deviations, that's getting into rare territory. So this first test statistic came out to be about 1 standard deviation. That's not crazy rare. We'll see how that ties into the conclusions we'll make in the next video. These two, however, are getting into rare territory. And we'll see how that shapes up with our p-values and our conclusions based on that. But we'll get to that in the next video. I'll stop here, and I'll ask you the question, what do we do with that test statistic now that we've got it? And we will answer this question in the next video. I will see you then.